Problems involving similar triangles and right triangle. Our objectives. At the end of this presentation, you should be able to solve problems that involve triangle similarity and right triangle. Let's start. A pole 10 meters tall casts a shadow 8 meters long, while a nearby tree casts a shadow of 14 meters. How tall is the tree? So let's represent the given problem. So there is a pole which casts a shadow of 8 meters long. So the measurement of the pole will be 10 meters and it casts a shadow of 8 meters. Now, as you notice, we can actually form a right triangle. And then while there is a nearby tree, wherein the tree casts a shadow of 14 meters. So we can again form a triangle. So the question is, how tall is the tree? So this is an example of a similar triangle because it involves two given triangle. So let's have first the given. So our given is the height of the pole, which is 10 meters, the shadow cast by the pole, which is 8 meters, the shadow cast by the tree, which is 14 meters. Now we want to find or the unknown, is how tall is the tree. Okay. Now let's have the solution. Since this is an example of a similar triangle, we can say that their sides are proportional. The corresponding lengths of its sides are proportional. So we can say that the height of the pole is proportional to corresponds to the measurement of the tree is proportional to the shadow cast by the pole corresponds to the shadow cast by the tree. So let's substitute the given value. So we want to find for the height of the tree. So to get the measurement of the height of the tree, so that will become 3 is equal to the height of the pole times the shadow of the tree divided by the shadow cast by the pole. So we got the 3 is equal to, so I just simply cross multiply this, and then whatever the value of this, we will just simply divide by the shadow of the pole. So the pole is 10 meters times the shadow of the tree, which is 14 meters, divided by the shadow of the pole, which is 8 meters. So we got the 3 is equal to 14 times 10 is equal to 140. Divide by, we got 8. So we got 140 divided by 8 in decimal, that is 17.5. Since our measurement is meters, so that is 17.5 meters. Let's have the number 2 example. A triangle with side lengths 5, 11, and 15 is similar to another triangle with the shortest side of length 8. Find the perimeter of the larger triangle. So if we will draw, so you got 5, 11, 15. So obviously the corresponding side of the shortest or the shortest side of the first triangle will also be corresponds to the shortest side of the other triangle. So this is 8. So we want to find for this side and this side. So let's name this as ABC and this is DEF. So as we all know, the corresponding ratio of the length of the sides of the given triangle should be proportional. So we can say that side AB over the corresponding side of side AB is DE is equal to side AC. Corresponding side of side AC will be DF is equal to BC over EF. Now let's write our given. So your given are AB is equal to 5, AC is equal to 11, and BC is equal to 15. Also, DE is equal to 8. So our unknown is actually DF and EF. So let's find first DF. So I'll be using this equation. So to find DF, the formula will be, so we cross multiply this and this. So that is AC times DE over, so we got AB. So we got DF is equal to AC is 11 times DE is 8 over AB is 5. So let's multiply. So we got DF is equal to 88 over 5. So DF is equal to, so we got 88 divided by 5, that is 17.6. So the other technique that I'll be showing you is to find for EF. So you can apply this also in finding for DF. So for DEF, I will be using AB over DE is equal to BC over EF. So let's have AB over DE is equal to BC over EF. So we just simply substitute on the given. So AB is 5 over DE is 8 is equal to BC, which is 15 over EF, because that is the unknown. So let's have cross multiplication. So EF times 5, that is 5EF, is equal to 8 times 15. So 5EF is equal to 8 times 15 is equal to 120. Since I only want to find for my EF, so I'll be dividing both by 5. So EF now is equal to, so we got 120 divided by 5 is 24. Next example. A ladder 13 meters long is placed on the ground in such a way that it touches the top of a vertical wall 12-meter high. Find the distance of the foot of the ladder from the bottom of the wall. So this example is an application for the Pythagorean Theorem. So there is a ladder which is 13 meters long, is placed on the ground in such a way that it touches the top of the vertical wall which is 12-meter high. So if I'll be draw that, that is, we have a wall which is 12 meters in height, and there is a ladder which is 13 meters long. So I want to find is the distance between the foot of the ladder to the bottom of the wall. So that is. So obviously, given is my hypotenuse on one leg, and the unknown is the other leg. Okay? So remember, in the Pythagorean theorem, to find for the longest side or the hypotenuse, so let's say the hypotenuse is C, let's say this side is your A and this side is your B. So C is equal to the square root of A squared plus B squared. But if either of the leg will be the unknown, the formula is, for example, your A is the unknown, so that is C squared, or the square root of the longest side minus the square of the other leg. Okay. Same with if the unknown is B, so that is the square root of C squared minus A squared. So if I will be writing this into a regular triangle, we can say that this is 13, 12, and this is the unknown. Okay. Now, let's say this is A, B, C. So you want to find for the side BC. So this is one leg. Okay. So let's say that is your A. Okay, so your side A. So to find for the side A, so let's have first write the given. So our given is the height of the ladder, which is 13 meters, and then the height of the wall, which is 12 meters. So our unknown is actually the distance between the foot of the ladder from the bottom of the wall. Okay. Now, let's assume. Okay, so let's assume that x will be the variable for the unknown. Let x be the unknown. Okay, so we will be using the variable x. So we can say that x, or this is one side, is equal to the square root of the ladder, or the measurement of your ladder, minus the measurement of the height of the wall. So let's substitute. So we have x is equal to the square root of, we got 13 meters squared minus 12 meters squared. Okay? So let's get first 13 meters squared. So we got x is equal to, so we got 13 times 13, that is 169. So this is square root of 169 meters squared minus, so we got 12 times 12, that is 144 meters squared. So let's subtract. So we got x is equal to the square root of, so we got 169 minus 144, that is 25 meters squared. So get the square root of 25 meters squared. X now is equal to 5 meters. Therefore, we can conclude that the distance, okay, of the foot of the ladder from the bottom of the wall is 5 meters. Let's have the last example. The bottom of the ladder must be placed 3 feet from the wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? So I have a wall again. So there is a ladder again leaning on it, which is 12 feet. And the bottom of the ladder to the wall, so this is 3 feet. So I want to find is actually how far above the ground does the ladder touch the wall. So I want to find for the height of the ladder wherein it touched the wall. Okay? So this is the unknown. So same procedure will be applied. So let's say the unknown is your B. So if I will be writing this into triangle, let's say this is ABC. So this is your hypotenuse, this is your other leg. So let's say the other leg is the unknown. So let's have first write the given. So yung distance will be, let's say, 3 feet. And then the height of the ladder, let's say that is L, that is 12 feet. So let's say the unknown, okay, is, let's say, the height of the wall. Okay. So again, we will just simply apply the formula. Since the longest side is given, so let's say this is W is equal to the square root of the longest side minus the shorter side. This is L. Should be L minus B squared. So we got W is equal to the square root of 12 squared minus 3 squared. So 12 times 12 is 144. So we got 144 minus 3 times 3 is 9. So we got 144 minus 9. That is equal to square root of 135. So let's get the square root of 135. So write it into decimal. So we got 11.62. And since the unit is feet, so this is also feet. Therefore, we can say that the distance from the ground that the ladder touches the wall will be 11.2 feet. Thank you.